There's a photograph that stops people cold the first time they see it. On the left side, 7 mountain peaks, densely forested, rising above a gorge so deep that clouds form inside it. The photograph is dated 2013. On the right side, the same location, same angle, same valley below. Dated 2020. The 7 peaks are gone. In their place is a flat concrete platform sitting 1,771 meters above sea level, with a 2,600-meter runway painted across it. And at one end of that runway, nothing. Just a cliff edge. And 1,200 meters of open air down to the Yangtze River. That's Chongqing Wushan Airport. The Cloud Airport. Built by removing 7 mountains, filling a 45-meter valley with crushed rock, drilling 340 concrete piles 67 meters to bedrock. Grouting 40 hidden caves that nobody knew existed. And pouring enough concrete to build a structure larger than the Hoover Dam in fill volume, all in 4 years. On a ridge where the wind never stops and the temperature drops to -8 degrees in winter. When the first pilot landed there on August 16, 2019, he walked to the empty terminal, looked out at the gorge, and left. No speech. Just the look of someone who had just landed somewhere that shouldn't exist. Here's the number that sets up everything else. Before this airport, reaching Wushan County from Chongqing took 5 hours by road. Switchback mountain highways through the Three Gorges region, some of the most rugged terrain in China. Where the gorges cut so deep that entire river valleys sit invisible below the treeline until you're right on top of them. 5 hours each way. Every patient being transferred to a hospital. Every student going home for the first time. Every ton of agricultural goods heading to market. 5 hours of mountain road. After the airport, 45 minutes. That reduction, from 5 hours to 45 minutes, is not a convenience improvement. It's a structural economic change. It's the difference between a region that functions in local isolation and a region that's connected to the national economy. Between a community where emergency medical evacuation means hours of mountain road and one where it means a flight. Between a tourism destination that 6 million visitors per year can reach and one that 10 million more were being blocked from reaching because the road was the bottleneck. The airport didn't just change travel times. It changed what was possible for everyone who lived on the other side of those mountains. But to understand what it actually took to build it, you need to start not with the construction, but with the geology. Because the mountain that became the runway was hiding something nobody had seen. In 2013, survey teams evaluated every ridge in Wushan County looking for a viable airport site. The requirements were strict. Enough flat land, or flattenable land, for a 2,600-meter runway. Accessible terrain for construction logistics. Acceptable approach paths for commercial aircraft. And structural geology stable enough to support a runway carrying the repeated impact loads of Boeing 737s for decades. Only one location met the criteria, Taohua Mountain. And Taohua Mountain was 7 peaks. The decision to approve the project meant approving the demolition of a mountain range. Someone ran the numbers, $252 million total budget, and said yes. April 20, 2015. One button. One blast. 18,000 cubic meters of mountain displaced in 2 seconds. 4 years of work began that morning. What followed was a construction operation of a scale that's difficult to fully communicate in numbers but that the source footage makes viscerally real. 3 shifts, 24 hours a day, 365 days a year. The mountain never went dark for 4 years. 800 machines working simultaneously at peak operation. 45,000 cubic meters of rock removed per day from one peak alone, with 6 more peaks waiting their turn. The crushed mountain didn't leave the site. It became the runway foundation. Broken down, then built right back up, compacted layer by layer under strict testing protocols. Every layer had to be approved before the next one went on top. The broken mountain was rebuilding itself as a runway, from the inside out. But the mountain had secrets. The original geological survey identified a solid formation. What the survey missed was what was inside it. Cave 23, 12 meters wide, 7 meters high, sitting directly below the runway centerline. Nobody knew it was there until excavation exposed it. Then more. Then more. A week-by-week discovery process that kept finding hollow spaces in rock that was supposed to be solid. 40 caves total. Found one by one as construction proceeded. Each one filled with concrete before the work above it could continue. The largest, 18 meters wide, 8 meters high. 28 meters under the fill, triggered an immediate evacuation of the construction zone and 72 hours of continuous grouting through the night, with instruments monitoring whether the intervention was working in real time. 40 caves. 40 found. 40 filled solid. Not one missed. And meanwhile, a 45-meter valley was being filled. Day 1 of construction, 2 meters of fill in the valley. 43 meters remaining. Week by week, the valley rose. Week 20, full. The topography that had defined this landscape for geological time had been replaced by engineered fill, compacted to specifications that would support aircraft operations for decades. Under that fill, 340 concrete piles, each one a 7-ton steel cage, dropped 67 meters through the fill material to bedrock. The fill alone couldn't be trusted to hold. The piles carry what the fill cannot, anchoring the runway platform to the solid rock geology hundreds of feet below, invisible to everyone who will ever land on it. Then there was the problem of the ground itself moving. 40 centimeters of settlement dropped overnight in one section, enough to require immediate response. An independent cave the original survey missed completely, discovered only when instruments showed unexpected ground behavior. The construction team spent 4 years in a continuous dialogue with the mountain, finding what it was hiding and responding before those hidden features could compromise the work above. The precision required at the surface was extraordinary. The finished runway platform across 4.5 kilometers showed a maximum deviation of 28 millimeters. 28 millimeters across a 4.5-kilometer platform built on top of a demolished mountain range, filled with crushed rock, supported by 340 concrete piles driven to bedrock. That's not a tolerance achieved by luck. It's a tolerance achieved by 280 sensors buried under the runway surface, monitoring movement continuously, not during construction, not during inspection, but permanently. Forever. Every day the airport operates, those sensors are watching the platform move and confirming it's moving within design parameters. The mountain didn't just become the runway. It became a monitored structure that reports its own behavior, indefinitely. But the engineering of the platform was only half the problem. Because a runway at 771 meters elevation, on a ridge with no natural shelter from any direction, in a climate that delivers 200 millimeters of rain per year, 120 km/h winds, and temperatures that drop to -8 degrees in winter, that runway needs concrete that the standard aviation specification never anticipated. Custom concrete mix. Designed for 300 freeze-thaw cycles, the number of times per year the surface crosses the freezing point and ice forms inside the material. Standard runway concrete cracks under repeated freeze-thaw stress. The Wushan mix was developed specifically for this ridge's climate, with fiber additives that resist the thermal stress fractures that would destroy a conventional runway within years. Then, 1,573 meters of joint between concrete slabs, sealed by hand. Every joint. Because water entering a joint means water inside the slab, which means cracking when it freezes. No shortcuts on a runway that ends at a 1,200-meter cliff. At the cliff end of that runway, a 90-meter section of what engineers call crushable concrete, engineered to absorb impact energy progressively if an aircraft overruns the runway. The only thing standing between an aircraft that can't stop and the gorge is those 90 meters of material designed to slow it down before the edge. The inspector walked to the cliff edge, looked down 1,200 meters to the river, and wrote one word in his report. Pass. Now here's where the weather problem arrives, because the construction problem and the operational problem are two different things. And Wushan Airport has both. The mountain ridge where this airport sits generates its own weather. Clouds form at runway level. Not above the airport. At runway level. Some days the runway exists inside a cloud, with pilots making instrument approaches that require the precision landing system to function perfectly because there's nothing visible until seconds before touchdown. Without the instrument landing system, this airport works roughly half the time. At Wushan, where the alternative is 5 hours of mountain road, half the time is unacceptable. The ILS is not a feature. It's the difference between an airport and an expensive platform in the clouds. The terminal building was designed with a window specifically positioned so passengers can see the scale of what surrounds them, gorges dropping away. On multiple sides, the 12 peaks visible from every approach path. The landscape that the airport was built to connect people to rather than route around. 45 people run this airport. The smallest 4C rated operations team in China. They know what 4C means, the category that defines what aircraft can use this runway, and they run the operation that makes it work in conditions that would ground most airports. 5 centimeters of snow. -8 degrees. Runway cleared in 38 minutes against a required 60. The team doesn't just meet the standard. It beats it. Now here's the context that makes the engineering decision make sense. Wushan County sits above the Three Gorges, one of the great gorge systems on Earth, drawing visitors who want to see the Yangtze carve through limestone cliffs that rise hundreds of meters on both sides. Before the airport, 6 million tourists per year were reaching this destination. The road was blocking an estimated 10 million more annually who either couldn't or wouldn't make a 5-hour mountain drive. The airport didn't just serve existing demand. It unlocked demand that the road had been suppressing for generations. Tourism to the Three Gorges region connects directly to the economic health of communities throughout the gorge: boat operators, hotels, restaurants, guides, craftspeople, whose livelihoods depend on visitor volume. A grandmother in Wushan watched the mountain she grew up looking at disappear over 4 years of blasting and excavation. When the airport opened, she could fly from it. The workers who spent 4 years demolishing those peaks, the ones who ran 3 shifts through winters at -8 degrees. Who grouted caves at midnight under continuous instrument monitoring. Who compacted fill layer by layer and waited for each approval before continuing. Some of them cried at the opening ceremony. That says something that engineering specifications can't. Now the runway is being extended. The drills are back. 400 more meters needed. Same mountain. Same method. 3 more caves already found in the extension zone, found, grouted, carried on. The airport that taught engineers exactly how to read this mountain's hidden geology is applying those lessons to its own expansion. 40 million cubic meters of material moved. The equivalent volume of 15 Great Pyramids. 800 machines. 2,000 workers. 4 years. 7 mountains deleted. The runway exists on a cliff edge above a gorge that was among the most scenically spectacular and practically inaccessible places in China. Pilots call it the aircraft carrier in the clouds, the same nickname applied to the Huajiang Canyon Bridge. The same metaphor that keeps appearing when China builds infrastructure in terrain where infrastructure wasn't supposed to be possible. The 280 sensors buried under the runway are tracking it correctly. The 4 years of construction confirmed correct in a single graph at the opening ceremony, every data point from every layer of fill, every pile. Every grouted cave, behaving exactly as the engineers designed them to behave. The mountain is gone. The runway is there. And every 45-minute flight that lands on it is carrying someone who, not long ago, would have been 5 hours away. But there's one final question almost nobody asks. Why spend hundreds of millions of dollars deleting 7 mountains for a county that many people outside China had never even heard of? Because from an engineering perspective, this airport was never only about airplanes. It was about distance. Economists have a phrase that sounds almost too simple: the cost of distance. Every extra hour between a producer and a customer quietly makes an entire region poorer. Fresh fruit spoils before reaching markets. Companies refuse to build factories because shipping costs too much. Tourists decide the destination isn't worth the drive. Young people leave because opportunities are somewhere else. Distance compounds. What Wushan Airport actually removed wasn't just 7 mountains. It removed 4 hours and 15 minutes from every future trip. And unlike concrete, that time-saving compounds forever. Think about that for a second. If just 1 million passengers save 4 hours on every round trip, that's more than 4 million human hours returned in a single year. Time that becomes business meetings instead of traffic. Family dinners instead of switchback roads. Emergency surgeries reached in time instead of too late. Infrastructure has a strange property. People notice the construction while it's happening. They stop noticing the benefits once it starts working. Nobody wakes up thinking about the bridge they crossed this morning or the runway they landed on yesterday. They simply assume the world has always worked that way. That's probably the highest compliment infrastructure can receive. It becomes invisible. The most successful engineering projects eventually disappear from people's minds because they become normal. Children growing up in Wushan today won't think 7 mountains were sacrificed to build their airport. To them, flying from their hometown will feel as ordinary as taking a train. And that's the point. The greatest engineering achievement isn't convincing people something is difficult. It's making something incredibly difficult feel completely ordinary. There's another lesson hidden here. When people see photos of projects like this, they often ask, how could humans possibly build that? Engineers usually ask a different question. What had to be true before this became possible? Better geological mapping. Higher capacity excavators. More accurate GPS surveying. Concrete mixtures that survive hundreds of freeze-thaw cycles. Real-time sensors that never stop monitoring movement. None of those technologies is spectacular on its own. But together, they shift the boundary of what's considered buildable. History is full of examples like this. Every generation inherits engineering miracles that the previous generation considered impossible. Railroads crossing mountain ranges. Tunnels under the English Channel. Bridges spanning kilometer-wide straits. Now airports on top of mountains. The definition of impossible has always had an expiration date. And maybe that's the real story of Wushan Airport. Not that humans destroyed 7 mountains. Mountains have always been moved. Sometimes by rivers over millions of years. Sometimes by glaciers over tens of thousands. Here, they were moved by excavators, surveyors, geologists, concrete workers, and engineers in just 4 years. Nature spent geological time creating this landscape. Engineering spent 4 years rewriting one small part of it. Every airplane that lands there today is a quiet reminder that the biggest infrastructure projects are rarely built to impress people. They're built so that, one day, nobody has to think about the obstacle that used to be there at all.